Hello and welcome back to module number 4. Today we are going to cover probability theory, and we are going to cover two basic subjects in probability theory: the basic concept of it, and then the second part we are going to talk about Bayes' law. So, any experience, usually there is the probability of outcome. Example, when you flip a coin, we have heads or tail, or you picking a right answer in the exam, and each one of them has a value or grade, and so on and so on. So a random experiment is an action or a process that lead to several possible outcomes. There's a way for us to assign probability. There's the classical approach, relative frequency approach, and the subjective approach. Each one of them has a plus and a minus. So the classical approach is that if the experiment has the possible outcome, this method would assign a probability of 1 divided by n to each outcome. So we will need to have the sample space. What is the space that this experiment will be conducted? And then the probability of chance. Each sample has 1 to 6 uh, probability of occurrence in the sample space that we outline. And then again, if we are selecting students based on gender, and this is the probability. So again, this is the classical approach, and usually it is very restrict in sense of what we are allowed to do and how what is the sample space, and we do not have any maneuver in that space. Um, Example, a computer company stack the number of desktop system it sells over a month. Okay, so we have desktop sold and the number of days. And so in this case, from that, we can construct an estimate probability of event based on a sold on a given day in order for us to make this probability idea. So in relative frequency, that's what we are measuring. We are measuring the frequency based on days and based on sold desktop in order for us to make this prediction. So again, there is a 40% chances that this store will sell three desktop on any given day, and this is based on the 12 days that they conducted this collection. And why did we selected 40? Because probably 40 is better number than 17 that happens during 5 days. So the longer the days in this case, the higher the solution. And again, it's based on frequency. It's uh, there is an issue with that, and I'll explain that later. Another approach is subjective, and that is the degree of belief that we hold in the occurrence of an event. Example, drop from this class. And so or the number of people land on the moon, or the girlfriend said yes when you ask her to marry you. So again, this is subjective approach and doesn't have any idea or any premises with regard to the sample space that we encounter or what it the outline of it. So events and probability of event is a sum of probability of a simple event that allowed us to evaluate the event itself. Example, assigning a fair die. And so we have the space 1, 2, 3, 4, 5, and 6, and we can assign then values to that in order for us to assign what is the probability? One of the things that we have to remember, there is additional definition in probability. We have the term experiment, toss a coin twice. It is an experiment. Sample space is the possible outcome of the experiment. Event is the subject of possible outcome. And probability of event is the number assigned to an event. And all of those terminology will come together when experiment is the process in which we observed. An event is the outcome of the experiment. And again, we have a simple event and we have assigned values that will allow us to execute or to account in order for us to do that. And the sample space is denoted as S in compared to simple event is described as E. So sample event and sample space, and this is where I want you to remember that what is the difference between sample event and simple space. Event is a collection of one or more simple events. So the die toss, and again, this is where the A is an odd number, the B is the number minus smaller than 2. So A, this is what it will capture. B, this is what it will capture. That's the premises of probability. That's the framework that we're going to work with when we are talking about probability. The formula for using simple events is the number of simple events in A divided by the total number of simple events. So it is the idea that if I will lay out exactly, if we have one coin or two coins, and this is where it all comes to again, how many times we are tossing the coin and what is the probability of observing at least one head. And this is the outline of the premises. We have head and we have tail, and this is where the probability come into play with that regard. Another terminology that we often use in probability is called mutually exclusive. If events are mutually exclusive, if they cannot happen at the same time. If, for example, we toss a coin, either head or tail might turn up, but not head or tail at the same time. So this is the idea of mutually exclusive. Similarity or similar, in a single throw of a die, we can have one number show at the top of the face and the numbers of the face are mutually exclusive. So this is my idea of it. So if A and B are mutually exclusive event, then the probability of A happening or the probability of B happening can be consoled as a foundation, as a formula, PA plus PB, and in this case, PA equal PA and PB. That's the basic formula for mutually exclusive. For joint A and B, we are calling it a joint probability. BR's AB stand for the probability that both events happens. So, example, if A is equal head and B is head and tail and head, what is the probability of joint probability of A and B? This is where we will come and see what it will consist of. We also have the idea of independent events. Events that are independent if the outcome of the events does not affect the outcome of other. For example, if you throw a die and a coin, the number of die does not affect what is the end result of the throwing of the coin. So if event A and B are independent event, then the probability of A happening and the probability of B is happening can be formulated as A and B equal probability of A multiplied by probability of B. Independence is two events, A and B are independent, and in this case, this is the formula. The probability of A and B, the probability of A multiplied by probability of B. A set of event A is independent in case, and this is the formula for that. So in this case, drug test. A patient is a woman, and B, drug false. So again, woman success, men success, failure, and failure. Will event A be independent from if the sorry, will event A will be independent of the event B, and this is the issue of independence. Again, the issue of toasting a coin is a good example of it and how it lay out for us and what it will consist of, and we have the ability to claim it is disjoint if it's not independent. So independence event and how it be consulted, but we also have to take into account conditioning or conditional probability of B given A. And this is again the issue of what if another condition has to be mixed into the outcome. So the layout or the foundation or the formula for that is B divided by A with the PRAB divided by PRA. So example, in this case, patient is a woman, B is a drug false, and in this case, this is what will happen. Given A is independent of B, what is the relationship between A divided by P and the probability of A? So conditional independence is part of the equation, the conditional independence giving C in case, and this is the formula that we often use. For example, there are three events, A, B, and C, and we know that the probability, the event A is equal to probability B equal to the probability of C, and it's 1, 2, 5. And so in this case, we can see whether A and B are independent, whether A and B are condition independent giving C. All those things are probably part of our equation to mark everything, to know the condition of all the variable or events in order for us to know exactly what to do. Multiplication is also part of the two. And so if we, for example, two events, A and B, the probability that both A and B occur is, and this is the formula. So the idea here, we are multiplying the probability of A multiplied by probability of B giving that A occur. And the idea here is, again, this is how we apply. If the event A and B are independent, then the probability of A and B occur is as the following formula outline it. Example, in the certain population, 10% of the people can classify as being with high risk of heart attack. Three, people are randomly selected from the population. What is the probability that exactly one of the three are high risk? So define A as a high risk and is not high risk. So the idea here is that P, exactly one is high risk, is equal to P multiplied by H multiplied by N multiplied by N, because we have three people in this case. And so this is how we set it up in order for us to say that the probability that one of them will have a high risk is 0.243. I talked before about additional rule. Additional rule provide a way for us to compute the probability of event A or B, or both A and B occurring, that is union of A and B. And the formula for that is A or B and probability A plus probability B minus the probability of A and B. Why do we subtract this joint probability B from the sum of probability? This is why we are doing it, and that's what the rationale behind it. So again, this is the layout with that regard, and this is where we are adding everything up in order for us to do what is the probability. In this case is 0.46 with regard to the probability of A and B. But I started this entire conversation about the idea of mutually exclusive, the mutually occurrence, and now we need to define one more term. Mutually exclusive is the idea that one of the occurrence of the event must make the other one impossible. And so the idea here is that if we will follow the rule that B or A is equal A and B, only if A and B are mutually exclusive. So, for example, in large city like in Tampa, two newspapers are published, the Sun and the Post, and we know the circulation of the uh, two newspaper. One is 22% and the other one is 35. A survey revealed that 6% of the household subscribe to both the newspapers. So what proportion of the city household subscribe to either newspaper? So here is the idea of mutually exclusive come into play. Why is that? We have subscription of the Sun or the Post, and the probability of the Sun plus the probability of the Post minus the probability of the Sun and the Post will give us that the probability of the entire uh, equation is 0.51 based on our formula that we cover. So this is the basic idea of the outline of probability. In the assignment and in your assignment, you are giving a table, a simple probability table, A and B. And B has two values, B and B1, A and A1. And I ask you to evaluate event A, event B, event A or B, and apply to it. One of the things that I often been asked by students, okay, can we apply our package or our application to calculate that? So there is a lot of application out there for R. I'm not in this module, I'm not going to talk about R as a resource. Instead, I'm going to give you link to a website that actually give you the entire set in order for you to calculate that. It's quite simple and it doesn't require a lot of technical skills to run it. Just follow the instruction on the assignment so you will be able to apply to it in order for you to calculate the assignment. And again, assignment is quite straightforward. Okay, back to our outline. And now I'm going to talk about important concept on probability theory and the Bayes law and random variables and distribution. So one of the major events, and probably if you will search Bayes rules or law in YouTube, you will find thousands of videos trying to explain what it is. The idea is quite simple, but it is a little bit more complex when it will sink in. The idea here is that given two events, A and B, and suppose that A is smaller than 0, then we have the structure of the law itself, the rule itself. It is the idea of A and B divided by A, and it is equal to the following rules. And so in this example, is it raining day and the grass is wet, and it will allow us to calculate that based on the rules and allow us to calculate the idea of it. So it rains and the grass is wet is two indication to it, and the idea is that we are able to take one variable or one element from the formula in order for us to predict what is the result of it. If it rains, usually the grass is wet. And so again, the hypothesis, and the hypothesis I did not cover yet. What is hypothesis? Is hypothesis the idea of how we phrase the question in statistics? Usually it consists of condition, and the idea here is that we are trying to make sure is that the evidence that we will test will be applied to. It's a form of description that we are using in hypothesis. The idea here is that we are trying to capture the evidence coming out of our text, evidence in the text itself. So again, the issue of what is it entail and how to apply to it. And as you can see, what is known before, what is known the likelihood, and what is the outcome of this idea. So, but the issue of Bayes' rule is a little bit more complex and more complicated. And again, I will try to emphasize that we have a conditions, we have the idea of what it entail in order for us to see what it consists of and how to apply to it. And again, this is the end product or the end formula that we will run, and we will probably in the end of the semester we will be able to run it in R in order for you to do that. So again, a more complicated example, again, it rains, the grass is wet, and people bring umbrella is 3 dimensions, and this is how we apply to it and how to define it. So the R function in R, there's much more, but there is R packages that provide us the ability to run it. And I will not apply to it, I will not discuss it. I will leave it right now as it is, because I think I want you to be more comfortable with conditions and the idea of it. You will have an assignment. Part of the assignment in module number 4 is based on Bayes analysis. Let's see if you will see your reaction and see what it makes out. So that's it for now. I hope you enjoy it. If you have any question, please do not hesitate to email me or come to my office. Until next time, have fun.